significant amount. That's true. Morning, Gilbert's. So what can I do from 2-6? Okay. I think that this kind of covers both. Like if you understand these three drives, so can I pick one of these? What I'm I have preference on one of those. Oh, I don't mind doing one either. I think it's good to see again. Does anybody care which one? 2021, 22. Okay. Alright, I'm gonna pick 21. So if it's going to be differentiable, it's got to be two things. It's got to be differentiable and continuous. Like differentiable means it has to be continuous also. So when it has to be differentiable, we have to check both. So for continuous, this is a road, and they need to come together, which means the y values need to be the same. So ax to the fourth plus x plus 4 has to equal bx minus 5. So that has to equal that. And I know the x value is 2. So this is like 16a plus 2 plus 4. So plus 6 equals 2b minus 5. And I'm expecting like a second equation with two variables. So I have to work with this. So I'm going to leave it for now and see what the easiest way to get to it is in a second. So differentiable, so this is continuous means the y values are equal. Differentiable means the derivatives or the slopes are equal. So ax to the fourth, bring down the 4, multiply by a, leave the x and reduce the power by 1. 4ax to the third. Like if there were a 2 there, it'd be like 8x to the third. Multiply the 4 by the constant. The derivative of x is 1, and then the derivative of 4 is nothing. And then here, the derivative of bx minus 5 is just b, because that negative 5 is a constant. So that's helpful, because I know what b is, and I can just shove it in here. But I know x is 2. So what's 2 cubed? 8 times 4. So this is 32a plus 1 equals b. With me so far? So now I gotta find out what a and b are. So it's really just like an advanced algebra problem now. I'm gonna stick this in there for b. A ton of room here. So I'll get 16a. I have to erase some of this stuff. So I end up with 16a plus 6 equals 2 times b minus 5, but b is this stuff. So I just gotta solve that equation. More space. Where's this? So we got 16a plus 6 equals 64a in b, so I'm distributing. So plus 2 minus 5, so it'll be minus 3. Am I gonna get the right answer? This answer feels not happy. Yeah. So that's A. sides, y values, right? So negative pi, that's over there. What's the y value? What's the y value? 0. Negative pi over 2 is down there. So that's like negative 90 degrees. What's the y value down there? 1. Side of 0 degrees, so the y value over here. 0. Side of 90 degrees is the y value up there. Then we're just like bouncing back. So that's side. And I can draw that in. You got like curves. So it's like a parabola that flips like an upside down parabola, and then it'll just keep going. Parabola upside down, parabola upside down. And now that I step back and look at that, that is not just like the 1 and negative 1 are so different. Right? So if I were to graph the derivative of that, so I'm jumping ahead here quite a bit, but it's good to like start thinking through this. What I want to do is plot the slopes of this graph. So there are 2 spots where I know exactly what the slope is. There's only 2. Right there, what's the slope? 0. So then the y value on my derivative graph is 0. So the y value on the derivative graph is going to represent the slope on the original. So the other point is right there. My graph is so crappy. But it's right there, right? What's the slope right here? 0. So the y value of your derivative becomes 0. And then you don't know. Right here, is your slope positive or negative? Negative. Our job is to graph the slope as y values. So our y values need to be negative. They need to be below the axis. I know, and you don't necessarily, just trust me. Trust me, bro. The slope right here is negative 1. So I'm just going to put that down. It's negative. But then as I go, does this slope, as the surfboard goes, is the surfboard becoming closer to 0 or further from 0? Closer to 0. So that's why my graph is going to go up like that. I'm not going to do it yet. Right here, if that slope is negative 1, what do you think that slope is? Positive. I know that's 0, and then this one would be negative 1 again, right? Well, if you connect those, and there's no way you would really know how this looks, except for I'm kind of telling you. Do you know what that graph is? That is cosine. So the derivative of cosine, or I'm sorry, the derivative of sine is cosine. And hopefully that helps you understand a little bit of why. I know I'm jumping ahead to past what we've done to explain it, but I think it helps a little. Questions on what I did there? Alright, let me do, so let's do cosine. So let's graph cosine. Now I'm graphing cosine of x. Trying to make my 1 and negative 1 a little better this time. So cosine of negative pi is negative 1. Cosine of negative pi over 2 is 0. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Look at here, cosine graph. And now if I were to attempt to graph the derivative of that, let's see what that is. So this really continues and then goes back up here, right? So what's the slope at that spot? Keep in mind it goes back up. Yeah, it's 0. Take a guess what that slope is? 1. What's the slope right here? 0. want to show you one more. So if I were to graph y equals e to the x, it looks like this. That is the point 0, comma. Because if I raise e to the 0 power, my y value is 1. So I want to think about the derivative. It's the only function that works this way in like all of math. The y values, if I ask you to describe the y values as I were going this way, I think what you would say is they're never going to be 0, right? You start a little bit above 0 and you start getting bigger and bigger, and as you go, you get bigger and faster. Does that describe the y values? Y values start off close to 0, they get a little bigger, and as you go, they go faster. Well, if I ask you to describe the slope, you would describe it the exact same way. So the slope here is never going to be 0. It's going to be really close. Then what happens to your slope as you go? It increases. The only function that works this way, the derivative of e to the x, is e to the x. So if I were to graph the slope, it would just jump right on top of this, and it's the exact same the whole way. That's everybody's favorite. It's like the easiest to remember. Alright, let's look at like the actual notes. So go to 7. Okay. So cosine, the derivative of cosine is negative sine of x. The derivative of sine of x is cosine of x. If it starts with a c, your derivative is negative. So then a couple things with this. One is they're reminding you like the plus minus rule. You guys don't even think about this rule because you don't need to, but it's just like, okay, take the derivative of this and then subtract the derivative of this. So that's what I should try to remind you about. The second thing is this constant in front, like what do you do with that? So let's say I had y equals 4x squared. What is the derivative of that? 8x, right? You bring the 2 down, multiply by 4, reduce the power by 1, so now it's just in the first. What if I decided instead of doing it that way, I wanted to just like remove the 4. So I'm going to like factor, I know there's only one term there, but I'm going to like forget it's there. I'm going to take the derivative of the x squared, and then I'm going to multiply by 4. So what's the derivative of x squared? 2x. So don't I still get 8x because 4 times 2x? What I'm trying to get at here is that constant in front just like drops straight down. So the derivative of 2 sine of x is just 2 cosine of x. So it's like you factored out the 2, you took the derivative of the sine, and then you just put the 2 back. So it really just kind of drops. And then the derivative of cosine is negative, right? So this will turn into plus 5 sine of x. Because the derivative of cosine is negative sine. Again, that constant just drops down. And that's the same if it's in front, like if I gave you y equals 10 e to the x, the constant would drop and your derivative would be 10 e to the x. Okay. Can I erase this? So for these, should we do these though? What's ln of 1? Good. So that's, there's like an e down there. So it's like e to what power gives you 1. So the 0 power always gives you 1. This is saying e to what power gives you 0, which is impossible. This is what's anything with 0 power? 1. And then what they're trying to remind you of there is what happens with e's and ln's. They just cancel. So that's a, and that's a. So there is this rule, derivative of a to the x, so there'd be that rule still applies. But like, watch what happens. So the derivative will be, it was a to the x times ln of a, so it's going to be e to the x times ln of e. But what's ln of e? It's 1. So that's how we end up with just e to the x. So it's really like the same rule, just a special case of it. So some people choose to remember like just this, and then they'll be like, oh, I know if it's an e and that goes away. I think more people probably just remember them separately, but that's up to you. So if I were to do this example, the derivative of 2 to the x, so f prime of x, a is 2 there, so the derivative is 2 to the x times ln of 2. Notice that's not like a constant in front. That doesn't just drop. That's a number raised to a power, so it is different, but you got this formula for it. And then the 3 in front of the e to the x drops. And what's the derivative of e to the x? Is e to the x, so that would be your answer. And then we got these two down here. It's kind of the same deal. It's one rule and a special case of it. So the derivative of log base a of x is 1 over x times the natural log of the base times natural log of a. I'm not really going to prove that to you. But if, because when you're dealing with ln's, the base is actually e, right? So if you're dealing with ln, which is really this, it's going to become 1 over x times the natural log of what? Of the base, which is e, and then what is natural log of e? Just goes away, so this one's just 1 over x. So the derivative of ln of x is 1 over x. But it's really the same rule, it's just like you choose to remember the special case for it. By far the most common ones are the e to the x and the natural log. These two are used not as often, but you still get them. So if I were to do this example, log base 4 of x, so that's this rule where a is 4. So that'd be 1 over x times the natural log of the base, so times the natural log of 4. Minus, so that 4 just drops. And then the derivative of ln of x is 1 over x. So that's an answer. More commonly, you would combine these two and say that's 4 over x. There might be some times you have to get a common denominator there, but not yet. So it's really just like, here's a bunch of rules they've memorized, practice them. There are still like, find the equation of the tangent line, find when the tangent line's horizontal, like that stuff is still involved. It's just now you got to trick with it. There's nothing like really new to teach except for just here's some definitions. So go ahead and start working. Let me know if I can help. Oh wait, are there more? Are there more for me? There are, aren't there? I'm sorry. Let's keep going. I thought these were yours. So 2 sine of x. What happens to that 2? Just chills, drops. Derivative side is cosine. 5 e to the x, the 5 just drops. Derivative of e to the x is e to the x. Go ahead and do 2 and 3 if you haven't already done it. 4 and 5, now you gotta work with them a little bit. So you're just finding the value and then plugging in. You're finding the derivative and then plugging in. Let's go through a couple. So the derivative of 3 ln of x, 3 drops. The derivative of ln of x is 1 over x. Plus derivative of e to the x is e to the x. So they're asking for f prime of 5. So there's really not much you can do besides just plug it in. So that'd be 3 fifths plus e to the fifth. It's like 3 times 1 fifth, so 3 fifths plus e to the fifth. Which if they ask for a decimal, you can throw in your calculator, but if they don't, you can just leave it right here. Because all that's left is addition, subtraction, multiplication. So that is illegitimate. Is that alright? So try 5 then. You guys don't like strings much. So your derivative, that starts with a c, so the derivative is going to be negative. And the 3 drops, so cosine becomes sine, negative sine, and the 3 is still there. I would look at that like 1/2 times sine of x. Sine of x over 2 is a fraction. We haven't really talked about how to do fractions, and even when we do it, it sucks. So I want to avoid it. So that's the same thing, and then the 1/2 just drops. Take the derivative of the cosine, or the sine, and you get cosine. So now f prime of pi, negative 3 sine pi, plus 1/2 cosine pi. So sine of pi, so pi is over here, what's the y value? That's the x value. 0 plus 1/2 times gauge over here, what's the y value? Negative 1. So that, you could leave it, that's negative n. So that's what I mean. Like, you still have to know how to do the stuff, like take the derivative and plug in, find the tangent. It's just now they're just treating it easy. How to do stuff. And it's work. Let me know what I go up with. So Clark, let me a video.